Good morning. I just wanted to give you a quick intro video to Experiment 2A, Intro to Qualitative Observations. We'll start here at the top. Remember to record your data and the observations in your lab notebook first. So don't start on the report sheet until you finish the experiment. Then we have the introduction. So the idea here is we're going to be taking some copper metal and carrying out 5 different reactions that convert copper into different compounds. And then at the end, we're going to regenerate the metallic copper. So the idea here is not really studying the individual chemical reactions, but they're really cool to look at. And we're going to get a little practice, at least watching some techniques. And it gives you a lot of opportunity for making observations. And so that's the big thrust of this experiment, is learning how to make observations. Qualitative observations do not involve numbers, they involve qualities of things, so colors, etc. So here are the chemical reactions that we're going to be doing, and you will need to refer to these chemical reactions. They're going to help us understand what's going on. Next is a section about recording qualitative observations. So this is important here. Observations should be recorded in the past tense without any personal pronouns. So that means you don't say I or we or they or she, anything like that. We pretend that people weren't there, I guess. And it's past tense because it's what you observed in the past. You should record these with enough details so that someone else doing this experiment would draw the same conclusions from the recorded observations that you do. And we should not have conclusions in our observations. We will draw conclusions from the observations, but the observations themselves do not have any conclusions. So we're using our senses to make these observations, and then we have a long list of examples of different types of observations. Formation of a precipitate. So that's a solid that forms. That's going to happen in this experiment. Well, what's the precipitate like? Here are some common words. Flocculent is a one that my students often enjoy. For some reason, it's just a humorous word. Flocculent. That means it's a fluffy precipitate. So when you observe that a precipitate forms, don't just say a solid formed. Tell me what kind. What was the quality of it? What was the color of it? There's a lot of color changes here. Be as descriptive as you want. There's no exact right answer for the description of the color. What color does it look like to you? Gas evolution, if we see bubbles forming, or we can hear fizzing, which you can't on the videos, but you can see the bubbles, so that's gas evolution. Heat evolution or absorption, that's going to be tough in a video, right? But that means that the reaction's getting warm or getting cold. Sometimes there are no changes at all. It's important to remember that no changes doesn't mean that nothing's happening. It just means that there's something happening that we can't see. So here are some other things to include in your observations. Amounts of things. Is it a lot of precipitate? Is it a little precipitate? Concentrations, masses, volumes, etc. Clarity. So clear means that you can see through it completely. Opaque means you can't see through it. And translucent is kind of in between. So these 3 words have nothing to do with the color, but they're how well can you see through it? And so if you imagine a glass of apple juice is clear, you can see through it, but it has sort of a golden yellow color, right? Size and shape of crystals. Again, color, different from clarity. Odor, not going to be able to smell that. Sometimes we need to talk about something happening at room temperature, and so we use RT as an abbreviation for that. Identity of known chemicals, the name and or the formula. What was done? Was it heated? Was it mixed rapidly, stirred, added dropwise, etc.? And then the rate at which changes occurred, instantly, quickly, slowly, etc. So then there's a list of examples. So this will give you an idea of a well-written qualitative observation. One of the techniques that we learn in this experiment is decanting. So when you decant something, it means that you're carefully pouring off the liquid and leaving behind the solid. So we allow the solid to settle out. It's kind of, if you think of a glass of water with sand in it, and you mix it all up in the sand, it's all dirty looking water. If you let it sit for a while, the sand and the silt will settle to the bottom, and if you pour carefully, you can pour the water off. So that's what decanting is. Percent recovery. Here, this sort of falls into the idea of conservation of mass. So we weigh the amount of copper that we start with, and then in theory, we should be able to get all of the copper back, right? Because the copper's not being created or destroyed. Now, of course, we know that things do not work perfectly, and so we will probably lose some of our copper along the way. And so we can quantitate this using percent recovery. So we're going to look at the mass that's actually recovered and divide it by the mass that's expected. The expected mass is the mass that we started with, times 100. So that's the one calculation you'll be doing. So then you'll go through and read through the procedure. So read through all of this. Notice these little indented sections with the double asterisks. These are hazards, right? So HNO3 is a concentrated acid. It will cause severe burns if it touches your skin, and the fumes are hazardous. So this is something that you're going to need to make a note of in the hazards section on your lab report. So that's something we would have to be extra careful with in the lab, and following the directions here. And then here's the video, right? So this video is my husband doing the experiment.
So for part 1, we need to get about 1/2 gram of copper metal.
And his style is that he talks to the camera, so you get a running commentary on the experiment. So that'll show you all these steps 1 through 4, and you're going to record observations in your notebook. One of the cool benefits of doing this virtually is that you can watch the video over and over again. So if you're not sure what you saw, you can go back and look at it again and record a better observation that way. So here's reaction 2. Again, there's a hazardous chemical here. You'll need to make note of that in the hazard section. You watch the video. And again, there's number 3, number 4, and number 5, the last one. So you go through all of that, and then you've got your data and observations that you wrote in your notebook, and those might be kind of messy. Now you're going to enter those into the fillable PDF. So here's a preview of that. I'm being a little slow this morning. And twiddle our thumbs and watch the little blue circle. Come on, you can do it. Well, let's talk about the rest of this and hopefully that'll load. So just reminding you about the instructions back in the introduction section for making qualitative observations. Okay, now we've got our thing loaded. So here's our report. The purpose, you're going to write at least one sentence, it might be more, telling what you're going to do and what method. So basically, what is the purpose of doing this experiment? What are we trying to figure out? And hazards. The previous experiment didn't have any hazards. This one has several. We're going to make a list of any hazards that are more dangerous than cooking in your home kitchen. We want to include a brief statement of how or why they're dangerous and how to protect yourself. So the short way of the protection thing is you can use PPE. That stands for personal protective equipment. That would be goggles, lab coat, gloves, etc. But these hazards are the ones that are listed up here, like acetone is flammable. So that's a hazard that should be listed in your report. I gave a reference to the procedure there, so you really don't need to do anything for that. And then we begin the data section. So again, you're going to type in the masses that you saw. And then for each reaction, I want you to copy the chemical equation from the lab manual. That's the part above. I did the first one for you. And then you need to answer the questions. And this is where you're going to write at least one descriptive observation. So here's reaction 1. And then here are some questions to answer about reaction 1. Now, read these questions carefully. They're a little challenging at this point in the semester because we haven't studied chemical equations yet, but you've all taken chemistry before, and I think you can figure this out. So what color is CuNO32 aqueous? So that means it's the solution that we're talking about. And again, you can go back and watch the video. What did you observe that indicated the formation of NO2 gas? Well, how do we know there's NO2 gas? Well, in our balanced chemical equation here, we see that we have a gas. The gas is NO2. And then a place for observations. Again, you need to write at least one good descriptive observation in there. Reaction 2. You can't see on this preview, but this is a fillable PDF, so there's a box here, and there's another box over here to type in the chemical equation. And the instructions about that are here. Do your best to make subscripts on the chemical formulas. To do that, you press and hold the control key and then press the equal sign. Then release them and type the number. When you're done typing the subscript, you do it again. I don't know if that's going to work on a Mac. You might know another way to do it. All I'm asking is that you give it a try. If it doesn't work for you, don't stress about it. Just use regular size numbers. It won't look quite right, but it'll be good enough. Okay? So you'll go through all of that, the different reactions. There's all kinds of questions here. What color is CuSO4 aqueous? So then, there again, it's asking you what's the color of the solution. What's removed when copper is washed and decanted? Include excess reactants. So if we go back and look at the chemical equation for number 5, oops, it's way up here. Scrolling. So if we look at these chemical equations, the result here is we've got copper solid, that's the solid, and we're pouring off the liquid. Well, what's in the liquid? Well, zinc and sulfate are in the liquid, right? And so by looking at this chemical equation, we can figure out what's getting poured off. The copper, the solid, is what we're keeping. The zinc and the sulfate are what are being decanted. So you have to do a little bit of detective work looking at these to figure out some of the answers. They're not necessarily going to be obvious. Calculations on mass of recovered copper, that's just some subtracting. Percent recovery, again, also pretty simple calculation. I did leave these as fillable boxes because these would not be too hard to type in, but if you want to write them by hand, that's fine as well. Results and discussion. So here's the discussion part. I've given you a prompt. Write at least one sentence discussing your percent recovery. So you're going to have a percent recovery, and at this point in your science career, you probably don't know, well, what is a good percent recovery? So I'm just giving you an idea here. If your percent recovery was less than 75% or greater than 110%, write a thoughtful hypothesis explaining why that might have happened. So how could you end up with 110% or 150%? That would seem to suggest that you have created copper out of nothing, which we know is impossible. So how could that happen? Well, it's most likely going to happen because of some sort of an impurity or wetness, right? If your final product is wet, then it's going to weigh more than if it was dry. And you record the mass, and your mass is wrong, and so it makes it look like you've recovered more copper than you actually did. So that's an example of a thoughtful hypothesis. And here I would point you back to that page I had in chapter 2, the reasoning, the claim, evidence, I forget the name of it, but there's a good little article there about how to make thoughtful hypotheses here. Okay, well, what if your percentage is between these? What can you say about it? Well, you could say that the percent recovery was very good, right? So this does not have to be a long thing, but I need at least one sentence there. Conclusion. So 1 or 2 sentences state the results you determined. Briefly summarize what you did. State the percent recovery. Okay, so this one you might think, well, how can I briefly summarize all of those chemical reactions? Well, you could say something like, you took copper was taken through a series of chemical reactions to form different compounds, ending up with elemental copper again, something like that. Okay? Then, post-lab questions. And here we're going to look at possible effects of error. So this post-lab is often misunderstood. So I'm going to try to explain it here for you. So how would the calculated percent recovery for copper change if these errors were made? We're not saying that the errors were made. We're saying if. What would happen? So you need to, it's not circle, you're going to click. You're going to choose one of the 3 choices. My percent recovery would be too high, too low, or not affected. So if some of the resulting solution in reaction 1 got spilled, what would that do to my percent recovery? Would that cause my mass that I get at the end to be higher, lower, or not affected? So to answer that, you're going to need to go back up and look at those chemical reactions. So here's the first chemical reaction, and it's saying the solution is spilled. So here we have aqueous and liquid water, so this is the solution. So if I lost some of this, what would that do to the amount of copper that I got back at the end? That's what we're asking you to think about there. Scrolling, sorry. And so there's a bunch of different things that could possibly happen, and we just want you to explain briefly what you think would have happened. Okay, so these fillable PDFs are really awesome, but they also cause some problems because sometimes you submit them, you did everything, it looks fine on your end, and then when I pull it up on my iPad, it looks blank. So I'm trying to give instructions here on how to avoid that. So you'll complete the report and then print it as a PDF. That's different than saving. It doesn't need a printer. So I put together some instructions for different devices here. And we may need to edit these and make these better, but this is what we're going to try. So do your best there, ask me questions if you need to. Then take pictures of your lab notebook pages. Save those as a PDF. It'd be great if you can put them into one file with your report, but if you can't, 2 files is fine. Submit the report and the notebook page files. I only need to see the pages where you wrote things for this experiment. I'm not expecting them to be neat and beautiful. I just want to see that you actually wrote the stuff in the notebook like you were supposed to. Okay, so there you go. That's enough to make you dangerous.